Today on How It's Made. Copper pipe fittings. Cylinder music boxes. Pepper mills. And hot rod steering columns. In the world of plumbing, it's all about connections. And we're talking about elbows, T's, and other fittings. Fittings hold everything together. They're also used to reroute pipes and control the flow of liquids. Without them, things just wouldn't flow as they should. With so many shapes and sizes to choose from, today's pipe fittings literally have all the angles covered. They start with sheets of copper. This copper has been refined until it's 99.99% pure. They load the sheets into a furnace that's fired at just over 1800 degrees Fahrenheit. The copper melts into a piping hot soup and then flows into a second furnace. This one has cylindrical molds, which draw the liquid copper up and cool it as they shape it into solid copper rods. These rods are flexible enough to wind through rollers as they travel towards a big spindle. They spiral around the spindle, accumulating in big coils to await the next step. This device uncoils the copper and chops it into little pucks about the diameter of a quarter. Incredibly, each one of these pucks will be used to make a plumbing fitting. This tool pushes the copper puck into a cylindrical die to shape it into tubing. In this one swift action, a little copper puck is transformed into a much longer piece of pipe. This copper has been reshaped as easily as a piece of putty. One end is closed, but it's just temporary. At the next station, equipment bends the tubing around forms to give it an elbow shape. At the same time, a blade cuts the closed end to open it up. Next, these elbows will get some fine-tuning. A two-part device comes together to steady them, as tools stretch the internal diameter so the part will fit on other pipes. A spinning cutter then carves bevels onto the rims. This beveled edge will allow it to slide more easily onto other pipes during installation. Over at the next furnace, they're working on a larger scale project. This molten copper will be used to make fittings for high-rises and other buildings with bigger plumbing systems. The copper flows into a casting furnace. It generates copper rods that are about the size of a telephone pole. Each one weighs about a ton, so it takes a crane to move it down the production line. A circular saw then carves them up, producing copper chunks that look a bit like firewood. They heat each chunk in a furnace to make it more pliable. Then it's into an extruder. It uses tons of hydraulic pressure to hollow out the copper log. At the same time, it forces the copper into a die that stretches it 12 times its original length and slims it down considerably. The lengthy tubing cools down in a milky bath. Then a crane moves it down the line to equipment that adjusts the diameter and chops it up. Water now flows into the shorter piece of pipe, which is encased in a mold. Tools push into the pipe, forcing the water in a vertical direction. Sheer water pressure reshapes the tubing into a T, while the mold establishes the contours. T-fittings are used to combine or split the flow of fluid in a plumbing system, and the water forming press does a seamless job of making them. But there's still the matter of the closed end at the base of the T, so they chop that off. They machine all three openings because when they connect it to other pipes, it has to fit. To a T, of course. Now, these fittings are ready to join other pipes and parts. And by doing so, they'll make our lives a whole lot more convenient. In Victorian times, the cylinder music box could make or break a party in the parlor. Its rich, ringing tones filled the room, and the design was truly a mechanical marvel. Today, that distinctive sound still resonates as companies make these instruments for a growing collector's market. Open the box, and you'll discover the gift of music from another era. Just wind up the mechanism inside for live music without any human performers. A cylinder revolves, and strategically arranged pins strum a comb to produce the notes. The ethereal sound is similar to that of a bell choir or a harp ensemble. It all starts with equipment that stamp and cut steel to produce a comb shape. A circular saw carves teeth in it, and this tool sharpens them. They bake the combs over flames and then plunge them into a cool oil to create a thermal shock that hardens the steel. With a flat tool, they direct melted lead into a mold positioned under the comb. The lead hardens into a weight that will help produce the low notes. A rotating tool cuts teeth into it. They now spread lead solder on the comb's edge and on a corresponding piece of lead. They file off excess lead and then tune the comb by first clipping the teeth, then grinding them until the notes they produce are precisely pitched. This bit of fine-tuning is computer-controlled. They dip synthetic feathers in glue and apply them to the bass notes to soften the vibrations. This completes the musical comb. They move on to the brass cylinders and drill holes in them to transfer the musical score. A computer controls this process, as well as the next one, which involves cutting steel wire and inserting it into each of the cylinder's holes. This is called pinning, and of course in the old days, it was all done manually and was far more time-consuming. Next, they pump resin into the cylinder, and it adheres to the wall, securing the pins from the inside. They spray compressed air to cool the cylinder as the resin cures. After an axle has been installed inside, they arrange the cylinder on a base plate and install little racks for the axle to turn on. The cylinder speed will be regulated by the governor. Using a special tool, they wind a long spring into its housing near the governor. It's the release of this spring's pent-up energy that will cause the cylinder to rotate and strum the comb. Positioning the comb next to the cylinder takes a certain know-how. If it's even slightly out of place, there will be a lot of sour notes. Dust can also affect the music, so they make sure to get every speck. It's time to attach the lever that winds the music box motor. This little spring completes the connection. They slide this mechanical musical instrument into its box, and it's showtime. The classic wooden cabinetry sets the stage for a musical act that has timeless appeal. There also are more contemporary-looking music boxes. This art glass design showcases the centuries-old technology. And then there's a version that comes with all the bells and whistles. Here, the cylinder operates cams that hit bells, while at the same time plucking the comb. It's a good example why the music box continues to be a tough act to follow. Ever since the 14th century, people have been using pepper mills to kick up the flavor factor, so they definitely have a well-seasoned reputation. Today, pepper mills come with state-of-the-art grinding mechanisms, and there are even electric models for a truly crushing experience. Freshly ground pepper has more spice than pre-ground pepper, which makes pepper mills a hot commodity. They make the grinding mechanism from tough, hardened steel. An automated chiseling tool carves teeth into the outer ring, making a row of larger ones to crack the peppercorns and a row of smaller ones for fine grinding. This smaller ring is to be the moving part of the grinding mechanism. After they stamp trademark information onto it, a tool etches teeth into it as well. They're designed to grind freely against those in the outer ring without locking together. Thick steel wire now uncoils and travels between rollers for straightening. Then there's quick chopping action, as a rotating cutter slices it into shorter pieces. Each one will become a drive shaft for a pepper mill. A tool slims and trims one end of the shaft so it will fit into the inner grinding part. Rolling cutters carve threads into the other end for attaching it to the adjuster knob of a manual mill. Robots install the inner grinding ring on the drive shaft. They randomly select parts for close-up scrutiny. A camera zooms in on the pepper mill's grinding teeth, and a computer analyzes their dimensions and general quality. Now it's time to assemble the grinder's outer ring, shaft, and inner grinding device, which they press fit to the pepper mill body. They surround the grinder with a metal ring and brace it with a bracket. They insert a light bulb to illuminate your food so you don't add too much pepper. Then they attach a test motor which turns the grinding mechanism and checks the bulb. A few units are selected to undergo a grueling test. They run them for hours at a time to confirm this production run can handle the daily grind. But a pepper mill just isn't complete without its partner, the salt mill. They use stainless steel to make its grinding device because it resists the corrosiveness of salt. Hydraulic machinery punches the metal into dies 10 times to shape the salt mill's outer grinding rings. Here, you can see the various stages of the forming process. The final result is a part with 3 large, jagged teeth in the lower section. They're designed specifically to move salt crystals towards the inner grinding ring. After a computer check, this part is ready for assembly. They install it in the salt mill housing and then insert the inner grinder and shaft. Once the electric motor is attached, this salt mill is done like dinner. For a traditional pepper mill, they sculpt wood into that classic shape recognized by pepper fans everywhere. They insert the same kind of grinding hardware that's used in the electric mills, but the shaft is longer because this manual mill will be quite a bit taller. Chefs often prefer a pepper mill with height because it's easier to use. Once assembled, the pepper mill gets a fill-up. Then they cap it and adjust the top knob to a medium grind. Of course, all mills can be adjusted for different sized grinds. From fine to coarse, the choice is yours. It's really a matter of taste. The driving force behind a vehicle's direction is the steering column. It connects the steering wheel to the front wheels. But despite the name, steering isn't the steering column's only job. It also houses the turn signal switch and a tilt mechanism to adjust the angle of the steering wheel. This company makes custom steering columns, the kind you order when building your own classic car or truck. For the main shaft of the column, an automated bandsaw slices steel tubing 2 at a time to a specific length. This belt sander smooths out the rough edges. The next machine forms the shaft into a specific shape that'll engage and turn with the steering wheel. A computer-guided laser cutter makes the steel housing that'll cover the steering column's upper components. It cuts holes for the various control levers that'll connect to the steering column. The upper housing now goes onto a device that holds it steady while a belt grinder removes any surface imperfections. Meanwhile, workers weld together the 2 steel pieces that make up the steering column's lower housing. Then, to make the steering column look sleek, they attach a steel cone using a fine welding torch. With an abrasive belt, they polish the weld line until it's barely noticeable. Then they do an overall polishing to make the entire surface smooth and ready to paint. They've attached a component called the lower yoke shaft to the main shaft made earlier. After greasing it, they snap an upper yoke shaft into it. These enable the shaft to pivot when you tilt the steering column. Here, they install a component in the lower housing to which they'll later attach the tilting mechanism. Once that's in place, they install a pull wire to help pull through the electrical system later on. Finally, they slide the shaft through the housing. A computer-controlled milling machine shapes the tilting mechanism's aluminum body. The next machine installs position-locking fingers, which allow the column to tilt when you pull the tilt lever, then re-engage to lock in the selected position. This press installs bearings to make the turning process smooth. Now the upper section joins the lower section. They attach with 2 pins that allow the column to pivot. A thick steel spring supports the column, so when the fingers disengage, the column doesn't just drop into the driver's lap. Next, they install the column's upper housing. That's the part with the holes for the levers to control the tilt, the turn signals, and the emergency flashers. Remember that pull wire? They tape the signal switches and wiring to it, then pull them through the column. They'll later cushion this exit hole with a rubber grommet to prevent any chafing. Next, they install the horn cam. It passes power from the horn to the steering wheel to enable honking. Using this tool, they lock in a retaining clip to hold everything together. All the wiring that passes through the steering column connects to a plug. You just insert it into the vehicle's electrical system. These steering columns come in a choice of finishes. You can also buy an unfinished column and paint it yourself. After installing the column, you just add a steering wheel, then mount the levers and knobs included in the kit. Then, from that point on, you're in the driver's seat.